Have you ever wondered how a small power bank can store electricity and later use that stored energy to charge your phone? How does electricity get stored inside it? And how does the power bank turn that stored energy into the controlled power your phone needs? Let's follow the complete process from charging the power bank to charging your phone. A power bank is a portable rechargeable battery system designed to store electrical energy and provide that energy to another device when needed. Inside its case are several important components, including a rechargeable battery, charging circuit, protection circuit, and output control electronics. The battery stores the energy, while the electronic circuits control how that energy enters and leaves the power bank. When you connect a power bank to a charger, electrical power enters through its input port. The power bank's charging circuit controls this incoming electricity before it reaches the internal battery. The charging circuit manages the voltage and current so the battery receives power under appropriate charging conditions. As charging continues, the battery stores the incoming energy through an electrochemical process. The power bank therefore does not simply store electricity like a container. It stores energy chemically inside the rechargeable battery and later converts that stored energy back into electrical power. Most modern power banks use lithium-ion or lithium polymer battery technology. Inside the battery are electrodes, an electrolyte, and a separator. During charging, electrical energy causes lithium ions to move and become stored in the battery's active materials. This process allows energy to be stored until the power bank is needed. When the battery is later discharged, the electrochemical process runs in the opposite direction and produces electrical energy for the output circuit. Now connect your phone to the power bank using a USB cable. The power bank detects that a device has been connected and activates its output circuitry. The battery's stored chemical energy is converted into electrical energy. However, the battery voltage is not simply sent directly to the USB output. The power bank uses electronic conversion circuitry to produce a controlled output voltage. The output circuit regulates the voltage and current according to the requirements of the connected device. The controlled electrical power then travels through the USB cable into the phone. Protection is another important part of a power bank. A protection circuit can monitor conditions such as battery voltage, current, temperature, and abnormal operation. If the battery becomes overcharged, deeply discharged, overheated, or experiences excessive current, the protection system can reduce or stop power flow. This helps protect the battery and the connected device. Every time the power bank charges another device, energy is removed from its battery. The battery's state of charge gradually decreases. The output circuit continues converting and regulating the remaining stored energy until the battery reaches a low operating level. At that point, the power bank may stop providing power to protect the battery from excessive discharge. The power bank must then be connected to a charger again before it can store energy for another cycle. The complete process can be summarized simply. Charger input circuit, battery stored chemical energy, output circuit, USB cable, phone. First, electrical power enters through the power bank's charging port. The charging circuit controls that incoming power. The battery stores the energy through an electrochemical process. When a phone is connected, the stored energy is converted back into electrical power. The output circuit regulates that power. The controlled power travels through the USB cable and enters the phone. Protection circuits continuously monitor the system during charging and discharging. So, a power bank is more than just a portable battery. It is a complete energy storage and power management system. It stores energy inside a rechargeable battery, converts that stored energy into electrical power, regulates the output, and delivers it safely to another device. That is how a small power bank can store energy today and use it to charge your phone when you need it.